Okay, great. Well, welcome to the few of you who have shown up. Maybe we'll have other people join in on the meeting. Today, we're going to have a little training on Tethys. We're going to specifically focus on GeoServer and web mapping capabilities with Tethys. And I think I've put together a presentation that will kind of illustrate a lot of the main concepts, at least to get you started. I'm recording this, so you should be able to access it later somehow if I can get that video. So I guess we'll just dig into it. In addition to kind of web mapping and GeoServer, we're also going to kind of cover some advanced user form stuff for getting input and feedback from the user as part of this. So what I'm showing here is my Ubuntu. This is actually, it's pretty much where I left off with the boot camp a couple weeks ago. I have my first app in there that I'll show you. So what we're going to do is create a new app to do the GeoServer stuff in. But the very first thing we need to do when we're working with Tethys is open up a terminal. It's this little black icon there, and activate our virtual environment. If you recall, it's this path, bin activate, with the dot in front. It's important. Or if you prefer, there's this little shortcut that I worked into the virtual machine for most people. .t, and we know it's activated because Tethys shows up in the left-hand side. So today, I'm going to introduce also Docker containers. One thing that is nice about Tethys is that it comes with a software suite. Let me open up the documentation, docs.tethys.ciwater.org. And if I go to the software suite link, you see the diagram of Tethys. And this little yellow-orange box down at the bottom is the software suite. And one of those components is GeoServer. Now, to make it easy to install, we provide GeoServer in a Docker container. If I just Google Docker, then you will see their website here. It's pretty cool. It's got a whale, containers on it. And what Docker really is, you can kind of think it as little micro virtual machines. They're stripped down versions of Ubuntu or Debian or Fedora or Red Hat, whatever flavor you prefer. And the idea is that you create a little container that has Ubuntu in it, and you install just what you want inside of it. And then you can take that container and run it on any operating system that you can install Docker on. And you don't have to configure it at all. It makes it very easy to install these software. There seems to be a little black magic behind it, but it works wonderful for our purposes. So if you're doing this at home later on, and I should mention I do not intend for people to follow along with this right now. I'm going to go pretty quickly so we can cover a lot of stuff, but I would encourage you to use the recording to follow along later. So to initialize the GeoServer Docker, you're going to use the command Tethys Docker init for initialize, and we're going to tell it to use the GeoServer Docker. Okay, and what that will do, mine's already been installed, so it says it's skipping it, but you'll see it start downloading different pieces of the Docker image that we can create the container from. And for GeoServer, that should take, with a good internet connection, about 20 minutes. It takes some time because it's about a gigabyte worth of stuff you got to download. Okay, after it finishes, then to start the Docker container, you use the Tethys Docker command again, but this time start. And again, container GeoServer. Okay, and it will tell us, in my case, it's already running. You'll probably see something that says starting Docker container. Okay, to prove that it's running, let me run this other command, Tethys Docker IP. What this does is it provides kind of the endpoints and the ports and hosts for the Docker where you can access it. Notice there are two others listed here, PostGIS Database and 52 North. Those are not installed right now. We'll probably cover those later in our trainings. So I'm going to copy just the first part of this endpoint URL and visit it in the browser. Now, if you recall, this host or this IP address, 127.0.0.1 is special. It means that it's running on your local computer. An alias for that is localhost, like that. Okay, and the port 8181 is where it's being served. And you can see it pulled up this little web admin page for GeoServer. The default username and password is just admin and GeoServer, all lowercase. That is in the documentation. So I'll go ahead and log in. Okay, it comes preloaded with a bunch of demo data. So if we look at this layer preview link, we can see all the layers that are loaded. One of the nice things about GeoServer is you can load data in many different formats and access it in even more. So for example, this top state layer, if I look at these are the available formats I can get it out. I can get it out as just a plain image, like a ping. You can see it renders that layer for us. It's just the states. I can get it as a vector format like GeoJSON, so I can actually manipulate individual features. Okay, and what's nice about this is that these different formats can plug directly into the map provided by Tethys. So we'll show you how to plug in these layers there. There are a few concepts that I want to illustrate that are important. One is stores. So if I click on the stores link, what a store is basically a folder on the GeoServer, but it's just a container that holds different types of files. So you can see they have different types. A couple of these are shapefile stores. We've got an ArcGrid store, GeoTIFF, and some others. So the actual files that you upload, in the case of this layer NYC, for example, is a shapefile, but the layer GeoServer serves it in more web-friendly formats for you. Okay, there are two other concepts that are kind of lumped into one in this screen, and that is resources and layers. The resources are the actual files that are sitting in the stores, so like your shapefile, and the layers are kind of the representation of that, that file. And layers are often associated with styles. So for example, there's this lake, where is it? I can't see it. Well, there's this line, there's grass. These different styles are what color the map. I think this population one is what colors the US states. So I'm not going to get a lot into those styles. GeoServer has really excellent documentation you can read up on, and you can manipulate all of these different things. You can add and create layers using Tethys, and we'll show you how to do that today. So those are the main concepts. The other one, so we talked about stores, layers, and styles. Layer groups are just what you'd expect. It's a group of layers. Those are really useful for providing a whole map. And then, so for example, we have, if we look at this Tiger NY, it's made up of several different layers, including these points, kind of this background map. I think there's a water layer, a park layer. So those layer groups can be used to kind of create whole maps out of multiple layers. And then the last thing is workspaces. And what workspaces are are just kind of arbitrary grouping of data. And in the, I guess the recommended use for workspaces with a Tethys app is to create a workspace for your app so that all of your layers and data are kind of grouped by your workspace. And I will show you how to do that. Okay, so that's a very quick introduction to Docker, to Docker and GeoServer. Going back to the docs in the software suite documentation, this talks about each of the different software components, and you can get a link to the GeoServer documentation here. And also I want to point out that it shows you what API to use. In this case, we'll be working a lot with the Spatial Dataset Services API. So I'm going to open that in a new tab. Okay. We're also going to be working with the Tethys Gizmos API. And if you recall, you can also access those through the Software Development Kit. We've got the Spatial Dataset Services API and the Gizmo APIs. Okay, so that's kind of our introductory concepts. Let's go and do something fun. So now that we have GeoServer running, I'm going to go ahead and start Tethys development server using Tethys manage start. Okay, and then I'll go into the web browser. Recall that is at the local host, port 8000. If you forget, it tells you right here when it starts up the server where it's serving. Okay, and what we need to do is associate our GeoServer with this Tethys installation. So I'm going to go to the site admin link. And in this Tethys Services panel, I'm going to go to the Spatial Dataset Services. And then there's an Add Spatial Dataset Service link. What I'm going to do is give it a name. This name you need to remember because that's how you will look it up. This endpoint, if you remember from our terminal, we printed out this endpoint. So this time I'm going to grab the whole thing, copy it, paste it. Again, we don't need an API key. Username is admin. Password is GeoServer, all lowercase. Okay, and I will save that. So now we should be able to access this GeoServer through our apps because it's been registered. Speaking of apps, we need to go ahead and make a new one for ourselves to play around in. So back to the terminal, I'm going to hit Control-C to stop the server. Go ahead and clean this up with clear. And I'm going to go into the directory we created last week. It's the home directory Tethys dev. Okay, and if I list the contents, you can see my first app is sitting in there. I'm going to create a new app in here using the Tethys scaffold command. And I'm going to call it GeoServer app because I'm not very good at thinking original names. Okay, GeoServer app for its proper name. And then I'll just accept the defaults for all these. Clear this again. And now you can see if I list that directory, we've got a new app in there. So we need to install it. So I'll cd or change directories into the GeoServer app directory. Okay, and I run Python setup.py develop. It prints out a bunch of stuff. Now I'll start the development server again. Tethys manage start. Okay, and you'll see, actually it does it twice, but it printed out that it loaded that app. So if I go back to the web browser and refresh it, Now I should have a new app. Go ahead and go into it. Oh, good. The decent color wasn't the pink one. Okay. So the first thing we're going to do to show you how to work with the Spatial Dataset Services API and GeoServer is we're going to create a page that allows us to upload a shapefile. And for that, we're going to need some sample data. I have beforehand, if we go to my desktop, I've downloaded some data that I've provided in the Tethys workshop directory that should be in the participants directory on the Google Drive. Okay, let me show you what that's called. It's called GeoServer and Web Mapping. So I downloaded that, and here I actually have the solution app for you to refer to. I have my notes that I'm working off of for you to refer to. And then in the data directory, I've got several shape files for us to play with. All of them are from the Utah database, because that's where I'm from. So we'll be playing with those a little bit. Again, that's on the Google Drive directory or folder in the participants directory that we shared with you during the boot camp. There should be a Tethys workshop directory with that stuff in it. And I'll send out a follow-up email with a link to that directly. All right, so let's work on making our upload form. I'm going to open Sublime and go to File, Open Folder, and I'm going to browse to my home directory, Tethys Dev. I'm going to select the GeoServer app folder so that we can see all of our files here in the pane on the left. Okay, I'll go ahead and expand some of these. So the first thing we're going to do, we're just going to be editing the home page to start with. So I'll open home.html. This is just the default home page. I'll get rid of the action buttons that are showing up at the bottom. And I'll clear out this app content block and add our own content. Put a header there, call it upload a shapefile. Okay. And then I'm going to create a form. If you recall, the form has kind of two major parts. Action. We're going to leave it blank to tell it just to submit to the same controller that this page is already using. Method. I like to use post. Remember, the options there are get and post. Since we will be uploading files, it needs to be post. And on that note, there's a special encoding type attribute that we have to specify for file uploads. That is multi-part /form data. Go ahead and close the form tag. Okay, since we are in Django, we have to always, in our forms, add this CSRF token. That's a security feature to prevent cross-site request forgery from happening, from someone hijacking your forms, basically. Okay, I'm going to create an input. Unfortunately, I don't have a gizmo for this one yet, but it would be an excellent one. I'm going to name it Files. Type is going to be File. And since shapefiles have multiple files that we need, I'm going to give it this multiple attribute so that it will accept multiple files. I'm also going to create an input named Submit. Type equals a submit button, so we'll submit our form. Okay, save my changes, and I'll refresh the page. Okay, so we've got our fields here. Now these buttons are not pretty, they're pretty ugly. So I'm going to introduce kind of a new concept. I'm going to Google Bootstrap. And what Bootstrap is it's you could think of it as a CSS framework, basically a styling framework for web pages. And it's built into Tethys. So it's available for you to use. I'm going to click on the CSS link, and over here in the menu, go to Forms. What we want is a nice, pretty form like this. And they give an example of how to do that. The way that Bootstrap works is you put classes, class attributes on different elements and kind of basically mimic this structure in your HTML, and it magically styles everything beautiful for you. Okay? So what I usually do is maybe I find an example I like I like how this looks, this email address, so I would copy that and paste it and then kind of move things around. For speed, I've done that beforehand. So basically what it involves is wrapping this input thing in a div and adding a label. So let me replace this here. This is kind of wrapping funny. Okay, so what I did is I created a div tag, and that's basically just a container division with this special class form group. I added a label. Okay, this for tells you which input the label is for. In this case, you point to an ID. So I had to add an ID to our multiple file input. And I also added this class to tell Bootstrap that it's a form control. Placeholder is the text that shows up in like a text field that is empty. Okay, so it would show up as shapefiles. Now that I'm thinking about that, I don't know if this one actually will use the placeholder, but that's okay. Okay, I also want my submit button to look nice, so I just add this class, button default. Let's go refresh the page. Okay, so that's Bootstrap. I have links to Bootstrap in the documentation. It's pretty easy to use. There's a little bit of a learning curve. All right, so now we have our little file upload. If I click in here, I could browse to files and select them. But it won't do anything at this point, so I won't do that right now. Now that our template's done, we need to modify our controller. You recall that's in the controllers.py file. Okay, and the home controller is already in here. So let's add some stuff here. Now what we're going to want to do is put these files on to GeoServer. And to do that, I need to import this function from the API. Okay, Tethys apps.sdk get spatial dataset engine. Okay, what this will do is it will return an engine object that has methods on it we can call to interact with GeoServer. This is best done through illustration, so I'll do that. So I'm going to create a new variable called GeoServer engine, and I'm going to use this method get spatial dataset engine. And the way it works is you just provide the name of the engine. Okay. I'll just remind you that when we went into the site admin portal, Spatial Dataset Services, we created this default configuration. Okay? So that's the name that we are referring to in our code. And so it will link us to that. Okay? Now, I also mentioned before when we were talking about workspaces that we'll want to create a workspace for our app. The trick is we don't want to create it if it already exists. So we'll do a little logic here to check to make sure it exists. If it doesn't, then we'll create it. So I'll show you kind of the pattern of working with these with this GeoServer engine object too. Okay, so I'm going to call a method called list workspaces. Okay, before I get too far down the road here, let me show you where that's at in the docs. Software Development Kit. We have the Spatial Dataset Services API. You know you're in the right place because it says powered by GeoServer. You scroll down about halfway, there's a link here to the GeoServer reference. Okay, and what this provides is a list of the different methods you can call on this engine object. So, for example, if I search for list workspaces, this is the method that we just called. So you can kind of peruse this documentation to figure out what you can do with GeoServer. Okay. So let's go back to the code. So what this will return is a dictionary. And why don't I show you a little debugging technique to illustrate that. You can actually print out this response object. Okay, and what that will do is print to the terminal. So I have to refresh the page to run that controller. So I'll go in there, refresh. And if I look here, you can see this dictionary printed out. It has two keys, result, if it was successful. If not, that will be error, and it will have a little message about the error, and success. And success will be either true or false based on whether it succeeded. Okay, so if you need to print some stuff out, you can see that in your terminal, your console. Okay, there's also a nice feature of all of these methods. They have this debug option that you can turn on. And what that does is it prints it out in a little prettier format. It's actually called pretty printing. Okay, so now it kind of lists these on top of each other. So you can see these are the different workspaces in our GeoServer. So what we want to do is check to see if our workspace for ours is in there. Okay. So on that note, I'm going to create a constant up here, denoted by all caps, that our workspace will be called GeoServer App. Okay, and that will be accessible to all of our controllers. So we don't have to define it over and over again. Okay, so let's do the logic to check to see if our workspace is there. So first, we want to know if it was successful. We don't want to do anything if it wasn't successful. So we'll do response success to see basically if that's true. We'll go into here. Then our workspaces, is going to be in the result field. Response result. Okay. Recall when we printed this out, we've got this result and the success field. Okay. And then we'll say if workspace not in workspaces. So if that string doesn't appear in that list of workspaces, then we want to create one. Response equals geo. We use our engine. We're going to call a new method called create workspace. Okay, and this takes two arguments. Let's look at the docs. So create workspace. So you can see it takes two arguments, an identifier for the workspace, that's the name of it, and a URI. Okay, it's basically a URL, but it doesn't have to point to a real website. It's just a weird ID. Okay, if you know the web address where you're going to be serving your app, a lot of times it's a good idea to use that web address and then maybe slash name of your app as your URI. Let's go back into the controller. I'm going to create another constant with the URI that I came up with. Okay, apps.nefi.org/GeoServer app. Space ID equals workspace. Okay, and URI equals GeoServer URI. Okay. And that should do it for creating the workspace. So let me open up our GeoServer again. It's on 8181/GeoServer. Should have left that open, I guess. Okay, and let's look at our workspaces. We don't have our workspace in there right now. Let's go to our app. Too many tabs. Let's move that over there. And we'll refresh the page. So now every time this page gets loaded, it's going to run through that logic and check to see if the workspace is in there. And we can see now it is, because we ran through it that first time. Okay. So now what we need to do is write the logic to handle the form. So when people submit their shape files, we've got to be able to upload that to GeoServer. So this is kind of the standard form logic to start with. First, we've got to check to see if the form was submitted. Oh, I better make sure I'm doing spaces. Okay. So the way we do that, remember it's in the request object, post because we use the post method, and we want to check to see if our submit button is in those parameters. Okay. There's a new thing where the files are stored, and that is request.files. And if you recall, on our form, we named our file input files. So we want to make sure that that is in this attribute, in this files object. Files in request.files. Okay. And if that's successful, it means our form is submitted and it has files. So we can go ahead and proceed. So file list, let's get a list of those files. Request.files.get list. And we just give the name of the input field, files. Let's go ahead and print that out so you can see what that is. So to illustrate that, I've got to choose some files. So let me go to my desktop, where I have those files from Google Drive. And actually, let's do counties. Okay, and I'll go ahead and submit that. So you can see we're still printing out our workspaces, so maybe we should get rid of that debug option. But the second thing is the list of files. So you can see there's one of these temporary uploaded files for each one of the files we uploaded. Counties.dbf, counties.prj, and so on, counties, SBN. So the files are quote unquote on the server. So now what we need to do is give them to GeoServer. So I'll go back to the controller. I'm going to get rid of this print statement so that doesn't get too cluttered. Get rid of the debug so we're not printing a lot of stuff out to the console all the time. Okay, so to upload the shapefile, we need to provide for it a name and a store ID. Okay, so for the store name, you're just going to have to trust me on this one. This is a little recipe for creating a random string with 6 characters in it. And for it to work, we have to import a few more libraries from Python, including random and string. Okay, essentially what it's doing is it's calling this random choice function on a list of characters. The characters in this case are made up of ASCII lowercase and digits or numbers. Okay, and we want 6 of them. The reason we're doing this is if we upload the same file or twice, we want it to be able to differentiate between the two, just in case they have, I guess if they have the same name, just in case they're different files. So this will essentially make sure that every time we upload, we're getting a new thing, a new store for the shapefile. Okay, the store ID, we want it to be stored under our workspace, and the syntax for that is workspace : store name. Okay, but we're going to construct that using our workspace variable up top, concatenate with the colon, and then concatenate with this store that we just created, this random digits and string or characters. Okay, and now we just gotta make the request. So we use our GeoServer engine again. The method we're using is create shapefile resource. There are several ways that you can use this. In this case, we can give it this file list directly, and it will take that and upload the files. You could also point it to files that are sitting in a directory inside your app or somewhere else on the server. So there are a few different options for doing this. So first argument it needs is the store ID, which we just created. It needs the shapefile upload. That's going to be our file list. Overwrite true. Okay, and I'm going to turn on debug so we know what happens to start with. Okay, so there's our logic. We check to make sure the form was submitted. It has files. We get the file list. We create a name for our store where we're going to put the shapefiles on GeoServer. And then we use the GeoServer engine to create the shapefile resource, giving it the name and the file list. All right, so let's go test that out. Again, I'm going to give it the counties. Hopefully I didn't misspell anything. It'll take just a minute to upload. Not a minute, but a few seconds. In theory. Okay, I'll go to my terminal. Remember, we turned debug on, and you can see it gave us back the success true. There is no result for it. Okay, so that worked. So in theory, we should see this in GeoServer. So let's look at our layer preview. And there it is, GeoServer. Notice it gave the layer the name of counties, which was the name of the shapefile. If I use this little open layers preview thing, I can see it's the Utah counties. Okay, Let's look at the stores. You'll see that we now have a new store that's just random characters and digits. It's a shapefile store, and it's under this workspace GeoServer app. So that's good. We are uploading files. So now what would be really great is if we could show these files on a map. For that, we need to create a new page. Okay. So let's go ahead and go into that process. So I'm going to right-click on this GeoServer app. And create a new file. And then I'll just save it. Call it map.html. Make sure it's in this GeoServer app inside your templates directory. Okay. And in there, what we're going to do is first we're going to extend the base template, and we're also going to load the gizmos. Okay. Then I'm going to create the app content block. And close that. Okay, and let's go ahead and give this page a header, GeoServer Layers, maybe. And then we're going to use the map gizmo. So gizmo, map view. And recall that it needs an options object to configure it. So we'll call it map options with an S. And now we've got to go into our controller and configure that map. So going back to controllers.py, I'll go ahead and first at the top, import the gizmos. So from Tethys apps.sdk.gizmos, import. Instead of importing individual pieces, I'm just going to import everything using the star. Okay. And we'll create a new controller called map. Remember, controllers need to receive a request object. Controller for the map page. It's always good to have a little documentation on your code. And let's go ahead and define our map options so we don't forget. Map view object. Height, we're going to say is 450 pixels. Width, we'll just say fill the screen, so 100%. And then layers, right now we won't have any, so it's just an empty list. In order for our template to use that, we have to pass it through the context dictionary. Map options will be what it will be referred to on the template. And then finally, to finish our controller, we just always have to return this render function. We give it the request. We give it GeoServer, basically the path to the template, which is map.html, and the context object. Okay, we're not quite done yet. We also need to create a URL map in our app.py. Okay. I'll make sure that this is using spaces, okay. We do that using this URL map object. Name will be map. URL, GeoServer app/map. So remember, GeoServer-app is the root URL of our app. You can see that by the home page. So we want this to be another level in. And then we give it the path to our controller using the dot notation. Oops, controllers. Go ahead and put that there. Okay. Now, go ahead and take a look at that. I guess this is our form submission page. I did not want to do that. We'll go to /map. And in theory, that should load a map. Great. It's a little squished. So maybe what I'll do is go back into my controller and tell it to be a little taller. 600 pixels. And refresh the page. That's a little better. Okay, so what would be nice is if we didn't have to manually type in this URL, if we could just use a link, perhaps in our app navigation. So to do that, your app navigation usually is consistent on all of your different pages. So I typically edit that using the base.html file. Recall that this is the file that your other templates are inheriting from, base.html. About halfway down, you see this app navigation items. And you can see kind of this pattern, but these are list items, and they have different classes to tell them to be styled differently. So for example, this app navigation title header shows up as a header rather than a link in our list. Okay, and then the links are kind of represented with these anchor tags. So let's go ahead and clear out most of these. What we want to do is just provide a couple of links. One to our upload page, and the other one to our GeoServer Layers page. Okay. Now, to provide the link to that page, we can use one of the built-in Django tags called URL. Recall I'm using curly % syntax here. And what I do is I just give it a string that represents the name of our app. So in this case, GeoServer app, colon, and the name of the URL map. So in this case, map. Recall we named this URL map. Not to be confusing. Okay, and then let me just make sure to close that with a curly brace %. So that will automatically generate the link to that page. Now we also want to do one back to our home page, GeoServer app home. That will allow us to get back to the upload shapefile. This active class will basically show the link as highlighted. Now there's a little logic that we need to get in there to do that. I'm not going to cover it right now, but we can do it later. But there is a way that you could do that so that it dynamically highlights based on what page you are on. So let's go ahead and refresh. Now you should see 2 links in your app navigation. One should bring you back to the shapefile upload page, the other one to your GeoServer layers. So that's kind of how you can start to build out your navigation and link to other pages on your app. Okay. Let's go ahead now and add some more logic to our map controller, because right now it doesn't have any GeoServer layers on it. So I'll go back to controllers.py. And then here, let me actually take a brief stint into the documentation. So if I go to the software development kit, template gizmos, and actually the Gizmo options object API, let's load that. I'm going to go to the map view here. This tells you all the different attributes you can assign to map view. Most useful are all the examples of how to use map view. What we want is a GeoServer layer. So you can see there's this example for a GeoServer layer. So I'm going to copy that. And I'm going to put it into the controller. Okay. Now there's a lot of stuff here we don't need right now. I'm going to delete the legend extent and legend classes. I'm going to hard code the title to be counties. And notice this URL is not correct. This needs to be our local host. 127.0.0.1. Report is correct though. We're going to use the web mapping service feature, so WMS, and then all we need to do is tell it the layer. Okay? And what the layer is going to be is our workspace for our app, GeoServer app, and the name of the layer, counties, if you uploaded the counties one. Let me show you that in GeoServer. So you can see the names here. We have GeoServer app, counties. So you can see actually, I accidentally uploaded it twice at one time. So we have another one here, another copy of it, and that's fine. So that's where I'm getting the name. We're just hard coding it for now. We will make it dynamic in a little bit. Okay, the last thing we need to do is add this to our layers list. GeoServer Layer. I'm also going to turn on the legend on the map. Okay, make sure we didn't forget anything. Let's go ahead and refresh the page. Be sure to save your changes. Okay, and there it is. Utah counties on the map. That's coming from the GeoServer we have running locally. Okay, that's great, but it's hard-coded. What I'd really like to do is be able to select from a list of layers. So I'm going to go back to my template, map.html, and I'm going to go ahead and add a select drop-down menu. And we're going to put it in a form so that we can pass that information to the server. Form, action, again, same controller, leave it blank, method equals post. Okay, we don't need the encoding type this time because we're not sending files. Like always, Django forms, we have to put the CSRF token in there as a security measure. We're going to use one of the gizmos called select input, and it will need options defined in the controller. We'll call that select options. And then we'll give it a button so we can submit it. Submit type equals submit value equals this time update. So on a submit type button, the value is what appears on the button, the title of the button. And then I'm going to add this button default class for a nice Bootstrap styling. Okay, I like to have 2 spaces for my tabs in HTML. Okay, let's go back to our controller and define the select options object for the select input. Okay, again, In our documentation, Gizmo options, we can go to the select input. We can see lots of different options here and examples. Okay. I'm going to go ahead and take this one, copy, put that into my controller. And I'll put it here near the top. Why not? Okay, but there's a few things we need to change. We need to select options here. The display text. Instead of that, what I want it to be is choose layer. For the name of it, I'm just going to call it layer. I'm not going to allow multiple options, so false. We'll leave the dummy data in there to test it. You can see the way it works is you kind of have these key values. Basically, the key is what shows up in the select box. This is the value returned when they submit the form. So the last thing we have to do is make that select options object available on the template. Man, can't type this morning. Okay, so let's go ahead and take a look at that. So you can see as we build out these apps, we kind of do it incrementally. It's always good to kind of test as you go so you don't get lost. So we are using select 2 for these select drop-downs. Nice thing about it is you can search them by typing. They have a pretty nifty way of showing multiple selected things, but we're just doing one. And notice our button says update instead of submit this time. And that's because we gave it the value of update. All right, okay, now we need to work in the logic. So they select a layer, we want it to show on the map. So back in controllers, we are going to, since we're working with GeoServer, we're going to need our engine again. GeoServer engine equals get Spatial Dataset engine, name is default. Okay. Now we're going to do this kind of an interesting way. By default, we want our options list to be empty. And what we want to do is loop through all the layers in GeoServer for our app and add those to that options list. So let's go ahead and get those layers. Response equals GeoServer engine dot list layers. Okay, and we're going to say with properties equals true. What that's going to do is instead of just returning a list of the names, it's going to return a list of the layer and all of its different properties. And there's one property in there that we need to use. Okay, to be able to filter it out for just the ones with our app. Okay, so now let's do our logic. So first, let's make sure that our list of layers came back successfully. So if it's successful, then what we're going to do is loop through those. So for layer in response, the list will be in the result attribute of that dictionary. And what we want to do is get the resource or layer name. Okay, and that's in an attribute called resource. Okay, so why don't we print these out so we can see what that looks like. Refresh the page. So you can see here are all the names. And notice that they've got the workspaces prepended, which is nice. these are the two that we want to show in our list because they're associated with our app. So what we're going to do is just check to see if our workspace name is part of this resource name. Okay. Get rid of that print statement so it doesn't clutter things up. So now we say if we'll use that workspace variable we defined before is in resource name, then we want to add it or append it to our options list. Okay, and we want it to kind of mimic this format. You see this options is a list of tuples, key values. So I'm going to actually append a tuple, and it's going to just be the same. Resource name, key and value will be the same. Now, if we were doing this for real, we'd probably want to find a way to make the key kind of a more pretty name than the value. Okay, so that will populate that little options list. Then what we need to do is instead of having this hard-coded data, we just tell it to use that options list with all our layers in it. So let's refresh. Okay, now you can see we've got our different layers. There's only 2 right now. If we go back to our upload page, maybe upload the Utah shapefile. Give that a second. Now we can go back to our layers, GeoServer layers, and you can see now it's added to this list. So we're kind of dynamically updating this list as layers are added to our app. Okay, so now the final bit is when they submit this form, we just need to tell GeoServer to use this layer instead of the one that's hard-coded in here. Okay, so we'll go back to our map controller, which is becoming pretty sizable. And what we're going to do is above this GeoServer layer, we're going to create kind of a similar pattern, an empty list that we will populate with the appropriate layer. We'll check to see if our form was submitted, request.post, using the pattern. And we want to make sure this layer input field is in there. Request selected layer will be the value of this request.post layer field, so the select input. Okay, what I want to do though is I want to kind of split it into parts so that we can make a pretty name for our legend. So I'm going to use a string method, selected layer dot split, and I'm going to split on the colon. Okay, if you remember, we've got workspace name of the layer, so we're just going to split it in half on that colon. Okay, and then using that, we can make a pretty legend title. That will just be parts. The second element in that list, there will be 2 parts. Oh, thank you. Let's not forget the equal sign there. We get an error. Okay, so now I'm going to move this GeoServer layer into my if statement by just tabbing in 1 level. So now it's indented, it's in that if statement. Instead of having this hard-coded value, I'm just going to put the selected layer. Instead of having hard-coded counties, I'm going to put the legend title. Okay. And then the last thing we need to do is in our map options, we need to append this to the map layers. Layers.append GeoServer Layer. Okay, remember we've made this empty list, we just added it to that list. Now this layers can just be replaced with that map layers variable. So we'll take the form, if it's submitted, we'll extract the layer that they selected, split it to make a pretty name for the legend, and then create our layer dynamically from that. Okay, let's go take a look. Oh, map layers is not defined. I must have misspelled something. Ah, that's right. Oops, let's go back. Refresh. There we go. So now notice nothing is on our map by default. The reason for that is in our controller, if the form has not been submitted, the map layers object is an empty list, so there are no layers. Okay, but if this is submitted, then it should populate that layer list with a layer. Okay, so we'll submit that, and there we go. We've got Utah showing up there. Let's switch it to counties. Okay. So now the annoying part is I have to zoom in every time. So let's play a little more with this layer, this GeoServer layer, and create some view options. So first of all, let's create some view options so that we have kind of a default zoom for our map. Okay, I use this MV view object. I copy this directly from an example on the documentation, and then I have to give that to the map. There's a parameter called view that will take that view options object. Okay. The way it works is you give it a center point and a zoom level. So now you can see we're kind of centered around the United States. Here's the center point. I told it to use this spatial reference for my coordinates, which is just WGS 84. And then I told it to do a zoom level of 4. I can also tell it I only want them to be able to zoom out or zoom in up to level 18 and out to 2 to control that a little bit. Okay, it'd be nice if we could zoom in on our layer as well. So in our layer, there is a legend extent option. And what it takes is an array of basically min x, min y, max x, max y. It's a bounding box. Okay, and this is in lat long. Okay, and also I want to add maybe some legend items to kind of describe what's being shown. So the way you do that is using this legend classes parameter. And there's an MV legend class object. This is a list, so you can have multiple of them. I'm going to say I want to define a polygon, give it the name county, which won't really be true for all our layers, but we won't take the trouble to make it dynamic right now. And I'm going to give it a fill color using hexadecimal coloring. This is just a nice gray. Okay, so here's our map before. Go ahead and refresh it. Okay, and now if I click on the layer, it will zoom to that extent for that layer. And you can see it's got this polygon symbol that is gray, and it's titled County. Okay, you can expand this legend, kind of play with the opacity, or even hide the layer. So that's kind of how you work with the legend. Again, this legend classes is a list, so you can add multiple classes. At this point, it's hard-coded, so you've got to kind of define those yourselves based on your layers. Hopefully, eventually, we can automate that a little bit. Okay, so that is pretty much what I wanted to show you for kind of GeoServer and mapping. The last thing I want to show you is how to get spatial input from a user using the map drawing features of Tethys. Okay, and for that, we're going to create another new page. So we'll go into the GeoServer app directory in our templates and create a new file. Save it. I'm going to call it draw.html. Okay. And here, to save time, I'm just going to copy it. We're extending from the base, loading our gizmos, and all I'm doing is putting on a map on this page. Okay. We need to define this map options and a controller for this new page. So let's go to the controllers. And down here, we'll do a new controller, documented controller for drawing page. Maybe that's self-explanatory, but it always helps others who are looking at your code. Okay, to add drawing options to our map, we have to define this MV draw object. Okay, and basically what we need to do is tell it what drawing controls we want on there. Controls, and I'm going to add modify. In fact, I'm not going to type all these out. There's a few of them. So I will just copy and paste. Again, this is in the documentation. And then we need to tell it which control we want to be enabled by default. I like the polygon one. Okay, now we need to define our map. Again, height 600 pixels. Width of the map, we'll make 100% again. Layers, we won't have any layers on this particular map. So we'll just give it an empty list. And then drawing options. So we give it that. To make it available to the template, we've got to pass map options to the template through the context, dictionary, Okay, and then render request GeoServer app / our new template draw.html and the context. Okay, so there's our new controller. Not done yet though, we've got to define our URL map that will map to that controller. URL map, name equals draw, URL, GeoServer app / draw, and define, point it at the controller. Okay.
He's not on now.
So, and then the last thing, let's go back to our base.html and provide a link in our navigation. So I'll just copy this one, change this to the draw, link, and then name this draw. Okay, so we'll go ahead and refresh that. Oh, but we got to go to the draw page. Good thing I made that link. Okay, so now you can see you've got these tools for drawing on the map. That kind of bounding box, lines, points. Okay, you can move them and edit them even. Click on it, and then you can add new nodes or just move the existing ones. This control just toggles off drawing. So there's a quick overview of the drawing features. Now what we'd like to do is be able to use that, get that data from the user. So let's go add some logic to our controller and also modify our template. So there is actually a hidden text field, basically, in the map gizmo, which means if you wrap it in a form, you are able to access anything that's in that text field when you submit the form. So I'll go ahead and define this form right around the map gizmo. Okay. Let's not forget to give it our CSRF token. That's just, you always do that. Change my tabs to 2 spaces. Input. This is our submit button. Let's actually make it pretty using the Bootstrap button default class. Okay, and then let's go to our map controller. And what we're going to do is we want to extract the geometry from that form. So by default, I'm going to create this geometry empty string. And then I'll do the standard logic for checking if the form has been submitted, request.post, and I want to check for that hidden field, which is named geometry. This is in the documentation as well. Okay. Then what I want to do is just replace the empty string geometry with the value request.post from that field. Okay. Now what I could do is I could add some logic here to take that geometry and manipulate it. But for our purposes, I'm just going to pass it back to the template so that we can just see what it gives us on the web page. So I create a new context variable called geometry, and I give it this geometry. So the behavior that this will exhibit is, by default, if the form has not been submitted, this geometry field will be empty. When the form is submitted, it will be filled with geometry. So let's go back to our form and print that out so we can see it. Okay, so I'll go ahead and use the if template tag, and I'll just say geometry. So basically, if that is defined, close the if, then print out this paragraph tag with the value. Remember, we use double curly braces to print the values of variables. Okay, so if it's defined, basically if it's not the empty string, then go ahead and print it out. Okay, so let's go back to our page. My virtual machine is slowing down quite a bit, so hopefully we didn't kill it. We'll go ahead and refresh the page, if it will allow us. Okay, so now I can draw on the map, do a rough sketch of the United States here. And if I submit this, you can see it printed out this geometry. Now this is in a format, a standard format called GeoJSON. You can actually Google it. It's basically just a standard for encoding spatial data using JavaScript. Nice thing about it, though, is because the JavaScript object syntax is very similar to the Python dictionary syntax, it works. There's a library in Python that allows you to convert it to Python objects. So you can work with this in your Python very easily. And when we go over databases and geoprocessing, we'll play with this a little bit. So, but that is kind of what it gives you. If I were to draw multiple shapes on the map, then there would be multiple fields in this output. Okay. So basically, it has these objects that tell you what type it is, provides the coordinates, and then there are properties that are associated with it, including the coordinate reference system. Okay, so that's all I have for kind of our web mapping and GeoServer tutorial today. I think we've gone long enough. Are there any questions that I can answer from anyone? If anyone is listening, I might just be talking to myself. I don't really know.
I think we had a little confusion with where we were going to broadcast from. We had a couple guys come in here about five minutes later. So.
Oh, great. Yeah. Are there any questions from anyone?
Hi, Nathan.
Hi.
I just have a question. Well, can you mention again, you're distributing GeoServer with Tethys, right?
Yes. Yes. So, and I recorded this video. So if you missed part of it, I showed how to get GeoServer basically installed with your Tethys installation, how to link it up, and how to add data to it and show the data that's in GeoServer on a map.
Okay, great.
Yep. Any other questions?